Good evening, everyone. Myself, Sushma, and the topic here is braking performance. The braking performance of trains is the general performance of the braking system of locomotives and cars and is a guarantee for the safety and improvement of braking declaration. In order to ensure the safety, the emergency braking distance in an automatic block section shall be definitely less than the length of the block section under the influence from self-stopping device, operating monitoring device or overspeed protecting system, etc. And this means that the passing speed of a train shall be strictly confined when the yellow light is on, ensuring that the train can stop at the red signal after emergency braking. It should be better to add a function on the monitoring device to control the passing speed of the train when the yellow light is on. In order to avoid use of emergency braking and to ensure easy speed control of the driver, it is advisable to adopt the uniform speed limit. The passing speed of the train when the yellow light is on. In the old section, for example, the speed of the freight trains may be controlled within 40 to 50 km per hour and passenger train about 60 to 70 km per hour. The braking performance of a vehicle is decisively influenced by the friction speed used, which consists of a brake pad pressing against a cast iron disc. This affects safety, braking, comfort, noise, vehicle vibration, pedal feel, and smoke generation, etc., and service life. The demands imposed on the friction system and particularly on the behavior of brake pads under a wide range of operating conditions are high and manifold. The capabilities of the braking system have to be constantly improved, owning the different vehicle weights, the fact that some vehicles have four-wheel drive, different maximum speed, etc. The remaining topics can be continued by Sushma.
This is additionally complicated by the introduction of add-on systems such as ABS, ASR, ESP, and brake assist. It should be obvious that different vehicles impose different requirements on the brake friction material used as part of the braking system. One or two friction formulations are not sufficient to meet the aforementioned requirements for different families of vehicles. Therefore, it is necessary to develop friction materials that are able to satisfy all of the predetermined requirements for specific vehicle families. These requirements are especially related to the need of the short bedding period, stability of the cold performance of the brake, stability of brake performance during speed changes, stability of brake performance under temperature load, stability of brake performance after temperature load, stability of brake performance under changes in the activation pressure, the relation between the static and dynamic friction coefficients, the friction coefficient under wet conditions and mechanical characteristics, compressibility, shear strength, bending strength, etc. A brake is a mechanical device that inhibits motion by absorbing energy from a moving system. It is used for slowing or stopping a moving vehicle, wheel, axle, or to prevent its motion, most often accomplished by means of friction. The braking in the process of reducing the speed of an induction motor. In braking, the motor works as a generator, developing a negative torque which opposes the motion of a motor. The function of the braking system is to retard the speed of the moving vehicle or bring it to rest in a shortest possible distance whenever required. The vehicle can be held on an inclined surface against the pull of gravity by the application of brake. Brakes are mechanical devices for increasing the frictional resistance that retards the turning motion of the vehicle wheels. It absorbs either kinetic energy or potential energy or both while remaining in action, and this absorbed energy appears in the form of heat. While moving down a steep gradient, the vehicle is controlled by the application of brakes. In this case, brakes remain in action for a longer period, making it imperative to dissipate the braking heat to atmosphere as rapidly as possible. Next, by continued by Gagana C.
What are the major factors of braking? Driving habits. Each time you step on the brake pedal, the brake rotors and paths wear a little more. By coasting, you can reduce the amount of wear you put on the reverse brake pedal. This helps you avoid accidents. Braking distance. When the cars ahead of you, slow down and take note of which areas around town involve frequent braking so you can drive more slowly through them. Brake quality. Whether the riding with OE brakes or aftermarket brakes, the overall mileage got out for the parts varies depending on the quality of components. And it should be expected factory brakes and high performance brakes to last longer than any bargain brakes. At some time or the another, most drivers will have to perform an emergency braking maneuver, be it due to hazard in the road or the car in front also stopping sharply. When it happens, then going to want the car to stop in the shortest possible distance to avoid an accident. Here, there are 10 factors that can have an effect on how fast a car can stop, and what measures are to be taken to reduce the stopping distance, and what actions to avoid that could extend it. These are speed, brakes, tire pressure, tire wear, tire quality, road conditions, view of the road, and distractions. Braking distance is the distance traveled after the brake is applied. It depends on two factors, speed and drag. There are two kinds of service brakes, or the brakes that stop vehicle while driving. Disc and drum brakes. Additionally, almost all vehicles come with emergency brakes and anti-lock brakes. Braking distance is affected by the speed at which the vehicle is moving and the weight of the vehicle, the road conditions, and braking efficiency, friction between the road surface and the tires, and the worn out tires will be left efficient.